Welcome to the Metasploit lecture for the Offensive Computer Security class at FSU in the Spring 2014 session. The outline of today's talk, we're going to go over a broad overview of the Metasploit framework. It's a very large framework, and start by going into the various interfaces for it. Then we'll talk about the database and workspaces and how to manage those and organize them, so the pen tests are very organized and easy to generate reports for. And then finally, Metasploit Utilities. We'll cover things like MSFpayload, MSFencode, MSFvenom, and Social-Engineering Toolkit. We'll have a demo for that. And this class is going to mix between new and mostly old lecture videos in case you're watching this again. So as a disclaimer, this class, Offensive Computer Security at FSU, has no affiliation with the offensive security team. The examples in this lecture are specific to Backtrack 5 and the Metasploit Framework version 4.6 and SET version 4.7.2. And as always, you are responsible for using this information in a legal manner. The difference between hacking and penetration testing is permission. So Metasploit is not a tool. It's not just a tool. It's a framework. It's a framework for automating various tasks for penetration testing and attacking. It allows you to string together complex tools in a big, grand attack chain that allows you to easily navigate victim networks. It is an open source project and has contributors from all around the world, and the features of it allow you to pipe the output from various scanners to a database for you to analyze and run perhaps signatures and heuristics against to detect possible vulnerabilities. For those vulnerabilities, you can string together various different exploits, and for each exploit you can have a host of different payloads for the possible architectures that may be on the target systems. And lastly, there's encoders, encryptors for defeating common filters and common signature-based detection defenses that you will find on networks. It's been around for a while. It's open source, is written completely in Ruby, and people who don't like Ruby tend to hate it for that reason. It's designed by H.D. Moore, who works at Rapid7, and it comes common with Backtrack, which is now Kali, Linux pen testing distro. And it makes life very, very easy. Some say it makes it easy like the movies, but we'll talk about that in a second. The resources for today's talk are the book, Metasploit Pen Tester's Guide, as well as the wiki for the offensive security team, Metasploit Unleashed wiki, which is pretty informative. It is about 90% of the same content as the book. Or the book has some useful demos, or rather examples of usage. There's also a whole host of tutorial videos at securitytube.net located at this URL, and they're about 10 to 20-minute videos ranging from Metasploit 101 to some of the most advanced topics of it. So it's like the Khan Academy for Metasploit. And SecurityTube is essentially the Khan Academy for many other subjects in cybersecurity. So hacking like the movies, they often get it wrong. Never seen anything like this. And this is a terrible monitor setup. I mean, why am I standing up and reaching all the way down? This guy's going to get terrible carpal tunnel syndrome. And yeah, this is from NCIS. I had to link it because there's two idiots typing on the same keyboard trying to beat a hacker, and it is just hilariously bad. Real life is usually way cooler. You can do all the stuff from your phone, and this is a screenshot of Dsploit. You could do it all from a drone, as I talked about last year, and usually your setups are ergonomic, cool, and slick.
Terminology going into Metasploit is that exploits refer to the means by which an attacker or pen tester takes advantage of a flaw within a system. A payload is the code that we want the pen testers or attackers want the system to execute in the exploit. So there are three types of payloads. They're called singles, stagers, and stages. We'll go over that in more detail in a second. Other main terminology is main components in Metasploit are modules. It's just an abstract thing. It's a piece of software that can be used by Metasploit framework. And then there's also listeners. And listeners are usually something done in hand with anything that involves a payload that connects back to the attacker. You have to have a listener to handle that connect back exploit, or often called reverse exploit. So this is the general architecture to Metasploit. The MSF core and MSF base are Ruby, basically libraries and APIs that tie everything together. MSF core basically defines Metasploit framework. MSF base makes it friendly to use. So MSF base makes it easy for all the modules to interface with all the components that MSF interacts with. It's worth mentioning that on this diagram, the database is not even included. So it allows for basically API to interact with the database plugin. So we have modules here, and then interfaces are basically the ways you actually get Metasploit as a framework to do things with all the other modules. And then there's things called utilities that basically are single-purpose functionality providers, or basically limited couple functionality providers for these modules. So the file system architecture for Metasploit, when it's actually deployed, is pretty simple. It shouldn't be confused with the file system that's set up for all the tools in Backtrack. That's totally different. The folder, the directory, wherever it's located in Backtrack, or whichever distribution you set it up in, housing Metasploit is intuitively laid out. Basically, data, it's all straightforward. Data has editable files that are used for configuration and whatnot. Lib is really what provides the meat of the code base for the framework. So if you really want to get into the code of Metasploit, you will find all the basically the good stuff there. And then scripts are in the scripts directory, plugins are in the plugins directory, and you can have private custom plugins that are actually located somewhere else. And I'll cover that. So I covered this, basically the main libraries, MSF core, MSF base. So modules are typically located in that modules folder, and so opt Metasploit MSF3 is the usual directory for Metasploit within Backtrack. And so it is actually very common for professional pen testers to write their own custom modules that they don't release, especially for things like encoders. Because encoders are a good way to defeat antivirus and intrusion detection systems. These companies that run them and maintain them take Metasploit and take the open encoders out there and run all combinations that you can think of and generate signatures for them so they can have a better hopes of defeating these things out of the box. So a lot of encoders fail in interesting ways, and it always makes life harder when actually the IDS is beating your encoder. So it's not too difficult to design a encoder for payload. So the modules basically are broken down to exploits, and what categorizes that is that any module that uses a payload is supposed to be located in the exploits module. Payloads are basically standalone that aren't accompanied by something that delivers it. And then encoders basically they do the encoding, the filter evasion to beat WAFs, IDS, AV. NOPS is straightforward. It's the tools to generate NOPS lists to keep things nice and even sized. And then there's miscellaneous modules and auxiliary. but also in auxiliary are exploits that aren't associated with any payload. And then there's also post-exploitation, which we'll cover another time. So that's all the modules right there. And let's get to the interfaces. So there's 3 ways to basically control the majority of the things in Metasploit. The first one, everyone, if they want to get to know Metasploit, should start learning. Otherwise, you kind of curb your ability to learn everything if you go another route, is MSFconsole. So MSFconsole is the most popular. It's command line. Basically, it provides its own command line prompt to the Metasploit framework. It's also the most flexible and the most feature-rich. You can do 100% of things that Metasploit can offer with this. It is also the most supported by developers and the community, and it's also the only interface that supports plugins, as far as I read on the Offensive Security wiki, I think. So MSFconsole, there's a number of ways to basically, whenever you're learning something, you should always learn how to figure out more information about stuff first. So help will generally tell you what commands are valid at any given stage, at any given context of the console prompt you're provided. And then for viewing options of a specific module, you can use show to see the options. Now to search for a specific exploit or module that you have in mind, you type search and then whatever keyword you're looking for. So to make use of a particular module, you would issue the use command. For instance, use Windows shell reverse TCP. And this would just be basically a payload. It's not an exploit, so there's nothing to drop it by itself. But you can see the options. Once you type use, the next prompt will be spawned in the context of that module. So then if you hit show options there, it'll show options of that context, of that payload. So what it lists here is basically the options that are required for this. The default settings are listed here in the current settings, and it says what's required. So there's one that's required that is not currently set, so that's always basically something you're going to have to set up. And it's pretty straightforward on how to do that. This overlapped a little bit. But essentially, in the same context, you type set lhost to be whatever the IP address that you need. For the attacker to listen on. Basically for the victim to connect back to. When you're done poking around in certain modules, you need to basically get back to the previous context you were in and the command line. You can do that with the back command. So if you want to use something, you hit use, and if you're done, you issue back. It's really rather straightforward. So this is one of my broken demos that I at least have backup slides for all of these things. So if I wanted to use an actual exploit, so exploit is something that exploits a vulnerability and executes a payload. Payload does not execute any vulnerability. It's just something that can be executed when when a vulnerability is exploited. So we're going to actually use an exploit, and we're going to exploit MS03026 DCOM. It's a tricky one to exploit because it's really old. It usually never works, but it's reliable when it does. But it also can cause a core system process to crash, and then Windows basically complains, you need to shut down in 10 seconds. But that's all an attacker needs to do a lot of nasty stuff, like add a new user account to log in again next time. So what you would do is you'd issue the use command for that, and then you can see the options for it. The only one you need to fill in is basically the IP address to set the target. So set the target of what machine you're going to attack with this. In this instance, I'm just attacking something that I've set up locally. And it doesn't exploit at that point. It doesn't execute the exploit at that point. There's two options. that involve this. It's one that's not always supported called check. Some exploit modules do support you checking to see if the vulnerability actually exists on the target. However, it's something that that module author has to implement the functionality of. So it's not always there. What always has to be implemented is the functionality to exploit it. So in this instance, I issue check and it reports back that it does not support the check. So when I issue exploit, you can see the commands or the activity of Metasploit here. It first starts the reverse handler, and then it starts targeting the victim, identifies as Windows NT family, and you can see it sends the exploit, sends the stage, and so the stage is going to be a interpreter session, and this essentially allows for a Linux-style command line shell access to a Windows system, which is very useful for people who aren't familiar with DOS and the command prompt of Windows systems. So you can type things like ls and ifconfig, and it will basically interpret it properly and handle it in the Windows style. And there's a lot of functionality that Interpreter offers, and we'll cover that in a later lecture. So the second interface to Metasploit is something that's less interactive. It's more of a one-off thing, and it's just single command line interface for Metasploit. It's important for, it was designed mainly to provide scripting, so you can strip many of the functionalities of Metasploit into various other tools, exploits, your own custom exploits. And early on it was designed mainly to allow more functionality and compatibility with other tools that perhaps weren't integrated in some manner to the framework or in a friendly way. So you can basically command line style type input and output between things. So it's not as user-friendly, but it still works. So this is my second broken demo. So I essentially have a screenshot of a Windows host and the IP address I have here. So when you want to select an exploit with MSFcli, you essentially have to know what you're doing. You can't navigate around, shop around for the exploits and the modules and search for things and then show options in that interactive way that MSFconsole offers. But you can still do this to an extent. If you specify what module you're interested in, you can show all the options with a capital O following it. So in this instance, I'm interested in using the MS08067 exploit that's shown in every Metasploit tutorial that just pwns Windows XP Service Pack 0, 1, and 2, and Vista Service Pack 0 and 1 systems out of the box, and provides high reliability of that. So the options on this show that you have to set the target, and everything else works with the default values. So setting the target here would be syntactically just a little bit different. You have it set on the command line here, and you use the equal sign as opposed to a space, which you would use in the command line. It's just a small little difference that's easy to figure out. So this demonstrates basically miscellaneous exploit, and we can tie it together with a number of different payloads. So in this instance, we want to just execute as our payload some shell code, some Windows 32-bit shell code that's going to open a port and just bind to it. And so the attacker will then connect to it. So you're going to open a backdoor and just listen for attackers to connect. And so when you set everything up, in order to execute it with MSFcli, you have to have capital E at the end. So I have this screenshot of it executing. It's a little difficult perhaps to see at the back of the room. But essentially, some interesting things that I'm going to note is that it automatically encodes the payload. I did not specify it to. It does it by default, a set number of times, I think, that's specified in a config file. And then it basically, once this has been exploited, it sends, it sends this stage. So this is the stager. So this is basically the second half of that screenshot, is that right after sending the encode stage in my console right there, I get basically a shell, system32. So, which brings me to the last interface for Metasploit. It's the most user-friendly because it's entirely point and click. So Armitage is a GUI that was designed by Raphael Mudd, and I spent a decent amount of time learning it myself. It's entirely point and click. It's hilariously easy to use. You can spawn it from any command line and backtrack, just type Armitage. The most interesting thing about it is that it was designed by him in his desire to make his life as a red team judge easier. He used to be a CCDC red team judge, and so this GUI allows you to, in a nice organized manner, manage exploiting many systems in a wide network. You can see basically all of them there in a panel. I have a screenshot of it next. And he went several steps beyond that, and he developed support for bots. So you can automate several aspects of Metasploit. So you can automate end mapping every now and then. And then once you say you've exploited a host, you can have that host end map to discover its neighbors. Perhaps it's in a different subnetwork. There was actually, well, before that, this is a guy who likes to write his own languages. So there's going to be some difficulty if anyone wants to ever learn this. It's basically all written in a language called Cortana, which is based off a language he also designed called Sleep. Sleep is basically a mix between Perl's regex, string handling, function parameter handling, and the rest of it's kind of like a mix of Bash. And so what's really actually interesting about all this is that a very recent update, I think last week or 2 weeks ago, supported scripting, third-party tools, and really interesting communication between bots. So you can have bots automate things, do things, and then communicate with each other. So essentially you have this nice point-and-click GUI that you can administrate casually a botnet. So it's fun. So it's fun to use. It won't provide as much functionality as MSFconsole or MSFcli, and sometimes it defaults to 32-bit payload. But so this is essentially what it looks like. You could, if time permits, I'll start it up and show you. But it takes a bit of time, and I have a lot of slides to get through, about 90. So I'll have a demo on this next week or so. So another important aspect, especially for penetration testers, is the database behind Metasploit, because it helps audit every single thing that a pen tester does, which is extremely useful for providing a report saying, I did exactly this and I can prove it. And you often end up doing a ton of things that sometimes you forget. It's nice having everything logged in a nice organized manner. So, like I said earlier, within MSFconsole, if you type help and a specific thing, it will show you basically commands that are involved with that component of the framework. So if you type help database, it will show you basically all the related commands. We see that there's basically a few reports that you can see. It'll dump credentials that it's had stored in it. It'll dump any host that's discovered from nmap scans. It'll dump any loot, which is basically any password hashes that have been stolen by any successful attacks done within Metasploit. You can also leave yourself notes, and many things log here as well. Services actually is it's basically every shell, interpreter shell, or shell that's been picked up by a listener gets logged in the sessions table. And so you can switch between sessions, and if you picked a session and done what you wanted to that victim, you can send it to the background and type background, and switch between sections on the fly. So at the end, I'm going to show you a little bit of that with the Social-Engineer Toolkit, which is just like, it's amazing. It'll probably blow your minds because you haven't been working with this stuff a lot. So vulns will basically list. I'll get to that. I have examples on that. So the database has to be configured a little bit beforehand, but it's built in with basically Postgres SQL. So it's really nice because it actually also allows for importing and exporting results from and to third-party tools. So if you have a tool that you like to use and it can export results in a clean manner, you can import those results into Metasploit so you have everything organized in that one same database. So that's really great for keeping results clean and organized. So you can actually organize the workspaces for whatever you're doing. So it always creates a default workspace and always uses it. If you want to create a new one, you just type workspace -A and whatever you want to name it. And again, this is all within the MSFconsole. So, and then you switch to it by workspace, whatever it is. You delete it with workspace -D, and if you need any help, workspace -H. So, like I said earlier, hosts is that database report that will list all the hosts discovered in an Nmap scan. Did you go forward or back? I don't know. Okay, so services will display all the open ports and services, and also, actually not all the open. It'll display all the information about all the ports and services gathered so far from the most recent Nmap scans. Like I said about vulns, as I was about to get to, any successfully utilized vulnerabilities and basically exploits or discovered vulnerabilities get logged here. And so that's an excellent way to basically provide a client of a pen test saying, this is exactly what I was able to exploit, and here are details. So this is a nice standardized way of providing this information. So the other options were DB underscore something else. So DB underscore Nmap scan is essentially Nmap, and it takes all of the output and puts it into the database right for you. So all of this information is used to populate the hosts and services reports. So you can import from other tools. Basically, you do DB underscore import, and you pass it basically the path, the absolute path. It doesn't recognize symbolic paths, so tilde won't work to your home directory, to wherever the report is. And it'll do file format auto detection, and it's pretty friendly. So it works really well with most tools that export XML results by default. So loot, like I said, will display, is populated with all the hash dumps and credentials stolen from victimized systems. So when, say, you're perhaps done gathering all that information for the day or with whatever you're doing, it's always wise to export the database perhaps to an XML file so you could import it later or use it in a report for later. It's also very wise for basically taking like snapshots or checkpoints of your progress. So the Metasploit utilities kind of take your standard tool and can make it go crazy in a good way.
Is there any utility, or is there any, like, does it provide functionality to sort of like replay? Let's say I've exported my work for one day and I have a multi-stage vulnerability, like I've done step 1 and 2 and I'm working on step 3.
Like
Can
to
I
rewind?
Well, like, can I just like sort of, if I've exported what I've previously done, can I sort of like replay what I've, is there any like replay or that kind of thing?
Not really.
Okay.
Because in most of these cases, you're dealing with something over the network. And when you're trying to recreate and replay and rewind in a friendly way, that you have to have complete control over everything and be able to control it on all ends. And
I just meant like replay as in like the commands that I've run so far, just run those again.
There is a command history. I don't know off the top of my head. So you could easily go by that and redo it yourself. There may be a way. So there's other interfaces to Metasploit, but they're typically called utilities because they typically just directly interface one aspect of Metasploit. So for instance, MSFpayload provides just basically access to the payloads module as well as ability to generate new payloads. MSFencode provides just access to the encoding modules. MSFvenom is really cool. It combines basically MSFpayload and MSFencode. And NASM shell is low-level kind of payload stuff. So NASM shell is what I'm going to go over first because whenever you're developing shell code on your own from scratch, you'll have to think about the null bytes. But it's really hard thinking just from the assembly level which instructions are going to cause a null byte when they're assembled. It's actually impossible unless you are actually an assembler yourself. And if you are, and you're sitting in this room, please come see me after class. It's going to steal your brain. So this is a friendly tool that's basically a command line interface that allows you to basically assembly instruction by assembly instruction, compile it, and see exactly what the opcodes are. So it works for 32-bit and 64-bit. I could show a demo of it, but it's really straightforward. You just find it in the framework, find /name nasmshell.rb would find it for you if it weren't in a standard location. So you would just type, if you wanted to see what XOR EBX assembled to, you would type it, hit enter, and it would tell you it assembles to 3.1D8. So it's really great for seeing exactly what instructions might be wise to avoid. And so when you're working with shellcode, you get familiar with various instructions, and you become familiar with them as being safe because you start using them over and over and over. So seeing new instructions that you might be considering using, this is a quick and easy way to check and make sure it's going to be safe in whatever shellcode. So that's all great if you actually want to work at that level. If you don't like shellcode and starting from scratch and doing it all, there's MSFpayload and there's MSFvenom for you. MSFpayload will generate simple shellcode in many different formats. However, I should note that the shellcode generation does not avoid null bytes, and it does not avoid any bad characters because bad characters are not shellcode specific. And I'll talk more about that in a moment. So to get any help with the MSFpayload utility, you type MSFpayload-H. So I mentioned there's 3 types of payloads earlier. So there's singles, stagers, and stages. Singles are basically self-contained and standalone payloads. It can be as simple as the assembly instructions to spawn firefox.exe or the assembly instructions to add a new user account to a system. Or perhaps it doesn't have to be at the assembly level at all. It depends on basically the vulnerability. So stagers, basically their purpose is to upload stages or payloads so that aren't self-contained. So essentially, the common purpose of stagers is to set up a reliable network connection between the victim and attacker and upload the stage or the payload over that connection. So sometimes it's actually common to have multiple stagers be chained together, depending on the environment. So stages are essentially payloads that are not self-contained and standalone and require such additional support for establishing a network connection. However, stages, since you establish that, often involve things like Metasploit consoles or not Metasploit, interpreter shells and PowerShells. So MSFpayload allows access to a vast array of different types of shellcode. And so for those of you who have hated actually writing your shellcode through the class, well, there's enough shellcode here that you'll probably never have to write it ever from scratch, unless you want to work on something brand new. So all of the shellcode that's here can easily be modified and customized. It's very well documented, and MSFpayload-L will list basically everything there is. And so when setting things up in MSFpayload, the options for the payloads are set by command line. So to see the options for perhaps the payload for spawning a reverse TCP shell on Windows 32-bit, you would type that and capital O at the end. And it shows you the information, shows you basically the architecture, which is x86, 32-bit. It even tells you basically if they listed the authors and how to contact them, if you have any questions. And then it tells you the options you'd have to set. And here you have to set basically the listen address. So which brings me to the next point. Once you set it up, you need to have some, essentially, you have to specify which format you want it to output. So this example happens to be x86 architecture. There's obviously a 64-bit version of x86. There's ARM. There's Atom, which is also x86 based. There's MIPS. There's PowerPC. Hardly even used anymore, probably on legacy systems still. There's tons of different mobile ones, and those are actually, there's very sparse collections of shellcode for them, but they're always interesting to look at. So there's different options for presenting, for commanding MSFpayload to present the output of the payload for you. The most commonly used one is raw. So for the architecture, it will basically output the raw instructions for that. So for x86, it's going to be raw, basically opcodes. It's going to be raw binary data. So if it were something else, say it's a client-side web browser vulnerability that you want to exploit, and you want to have basically this exploit hosted on a malicious website, and you need some way to execute it on the client's PC, well, a good option for the format of this exploit would be JavaScript. If the victim has JavaScript enabled, navigates to the site, it will execute this JavaScript that's given by the MSFpayload, and that will have the functionality of whatever you command it to. So here are some examples. So in this instance, I've set up basically the aforementioned example, specified the listener to connect back to, and the port to connect back to, and I have it export in C. So this makes it easy to test as well. And say perhaps it's actually a content management system or a web application vulnerability, and I can upload my own file. This is actually compiled in such a way that when it's escaped, it's rendered as valid PHP instructions. because it is actually, I think it's, yes. I guess it gets executed basically as Perl. So it's an interesting combination. I haven't actually viewed the source for it. So this will export it in basically PHP format, and that's supported there. So the mileage there will vary, and it can get a little confusing when mixing things with output formats that they're obviously never intended for, such as exporting a reverse Perl shell for PHP architecture to C. Obviously, never was meant to happen, and it's probably not going to work. So the problem with that is the MSFpayload does not avoid null bytes, and in many exploits, especially over the network, there are various other factors that can cause an exploit, cause a payload to fail, because there are things called bad bytes. In many networking protocols, such as like Telnet and others, there are bad bytes that actually indicate the terminator for that string, for that packet, or for that data. So /XOA, I think, is, I can't remember off the top of my head. I think it's new line or something. That's right? Yeah. So that would basically cause the exploit, the payload rather, to get truncated right there. And so you lose the rest of your exploit code past that. So MSFcode exists. Its input is raw output from MSFpayload. And so the raw output would be specific to whatever architecture it is. So if it's x86, it can be raw x86 instructions that have been assembled. So there's an important distinction that needs to be made, and you need to remember it, is that null bytes are shellcode specific. Bad bytes that cause the truncation of your payload or your exploit over the wire are exploit specific. So that's the result of some sort of operation being performed on the payload before the payload actually gets executed. So to combat this problem, MSFencode supports a number of encoder algorithms. And like I said, the security industry frequently watches these publicly available encoder algorithms so it can find all combinations of signatures to protect against them. Because nothing hurts your business more than some pen tester rolling up to one of your clients and just using everything out of the box and working and to pwn their systems. And so since they do that, smart attackers write their own. So those of you who have chosen to do that for your term project, kudos to you. So to list the various encoder algorithms for MSFencode, you would just give it -L. So the supported platforms so far are x86, x64, PHP, Spark, MIPS, and PowerPC. So the default encoder that MSFencode always chooses is Shikata Ganai. It's the only one that has been ranked as excellent by the development team. So they basically have a set of trials to grade the rank of these encoder algorithms. So in the list, it describes what it is, and in this case, it's a polymorphic XOR additive feedback encoder. So the source code for basically the encoder is somewhere there in the encoder module source. So if you are interested in writing your own encoder, you can actually look at how others have done it as well, and to make sure yours is novel and not going to get caught by these signatures. So many of these encoding options actually, even though this one's the default one and is ranked excellent, it may not be appropriate for all situations. So some of these are actually specifically designed for certain situations where others would actually, even though they're excellently ranked and totally reliable, would actually fail. So Which brings me to MSFvenom, which is a utility for basically generating custom shellcode. It's super easy to use. It's basically a combination of MSFpayload and MSFencode. It supports both 32 and 64-bit. Multiple architectures it supports, just like MSFpayload. You can actually customize the commands you want your payload to do rather easily, other than perhaps just spawn a shell. You could do something specific like add a user to the system, add username and password as a new user account to the system, or perhaps tell it to wget a backdoor or something like that. It's somewhat friendly to use. It by default generates encoded shellcode, and it actually is non-deterministic, so your mileage may vary because the choice it may have decided on to encode may fail, or may actually produce null bytes or bad bytes. So there are a number of important flags, and I have an example command here. So essentially the payload or vector is denoted with -p, and what follows it is essentially some sort of feature on that architecture that allows you to execute custom commands. For instance, in Linux, x86, the classic exec. Basically push the arguments in the right way, or however it's the calling convention is, and pass it basically the parameters you need to execute bin sh, for exec to execute bin sh. So this is exactly what would be set up for MSFvenom. So A here specifies architecture. I think it actually may be redundant in this case because it's specified there. B specifies actually the bad bytes to avoid almost always 00 should be specified. Yeah. But like I said, the encoder may generate encoded shellcode that does have zeros in it if it's not told specifically to avoid it with this MSFvenom utility. So -I tells it the number of times to actually encode. It is common for the encoder to encode with the chosen algorithm at least about 4 times. Sometimes it'll do 20. Maybe it'll do 100. Obviously, the more the better, even though, so think about it like this. Say you're an antivirus company and you have 3 encoders that are out there in the world. Let's say the security market is young. If you have 3 encoders, what you can do is you can take your payload, say encode it with option A, take the output of that, encode it with option B, then encode it with option C, and then so on, so on, so on. There's only so many, basically, possibilities you can iterate through at the end of the day. So as an attacker, the amount of times you choose it to encode, obviously, the better, because you're playing the odds there of how much are the antivirus companies and them actually willing to iterate through to add to their signatures. Because if they're willing to iterate infinite amount of times, then they're going to have to push out an infinite-sized file out to their clients to update their signature lists. And no client's going to like it when, hey, my antivirus just filled up my hard drive. I can't do anything now. So there's only a limited amount that they can actually do to go to beating this. So here's an example where I've instructed it to iterate 0 times. So there's no encoding done whatsoever. And you can see that there's actually no bytes being generated. And thus, if this is used in any sort of buffer overflow, this will fail. So when specifying it to iterate 3 times, it basically gives the output of each iteration. And you can see that the size of the payload increases with each iteration, which makes sense because you have to, unless someone comes up with a genius way to in place encode and decode everything in multiple iterative ways, I don't see how you could have this possibly be anything other than the way it is. And so this goes on past the page, and it doesn't generate any null bytes, any bad characters specified. So this example was basically for spawning binsh. Getting exec to spawn binsh. You don't have to go to that level of detail. You can use basically more standard Windows bind TCP shells. And you can also specify the encoder. So the most commonly used one, the Shikata Gainai, and so this would be the output of that. As you can see, the size increases with each iteration. So hopefully I'll get through everything. I want to make sure to stop me before it gets too late to go over the midterm. So this brings me to one of the coolest things that Metasploit kind of spawned and supports, and it's kind of like a symbiotic relationship almost. The Social-Engineer Toolkit is developed by the team at socialengineer.org. Chris Hagney, I can't say his name. He's an awesome guy. I actually contacted him out of the blue about something and he got back to me right away. I didn't even expect it. So it's always nice to see developers behind really big projects be responsive and quick with the community. So Social-Engineer Toolkit is something that has been, actually it's quite young, but it has had skyrocketing success and is now considered the industry standard for any social engineering penetration testing attacks. In essence, the Social-Engineer Toolkit augments your ability to schmooze people and manipulate people with a feature-rich technical arsenal. It has all sorts of amazingly creative ways to attack human stupidity, curiosity, habits, and the main terminology we need to talk about before going into it more is that basically it categorizes everything instead of Metasploit-like modules. It categorizes everything with attack vectors. So each attack vector category is basically an avenue for gaining information about or gaining access to a system. So there's web attack vectors, there's email attack vectors, there's USB attack vectors. Say you want to do Stuxnet again with someone else. There's tools that will let you do that. So the features in this toolkit allow you to automatically create and send credible looking with solid email headers, phishing emails. It allows you to, on the fly, scrape a website like PayPal or a bank or Twitter and clone it, and then you host it also automatically. And you can also spoof templates. It allows many different ways to do man in the middle. It allows the totally easy generation of custom malware, say PDF exploits that you want to attach in a phishing email. Also different custom exploits for a browser, vulnerability, custom media, say you want to exploit a flash vulnerability, custom QR codes, say you want to have a business card or some flyer around campus. Does everyone know what the 2D barcodes are now? They're QR codes. You take basically a picture with your phone and it'll pop it up in a browser on your phone. So if you have if you have a website that you can host basically malicious, if you have basically a mobile browser exploit, you can easily hone anyone that decides to scan that QR code. It also supports the automatic generation of custom applets that download stagers and so much more that I'm still learning. So there's a little bit of assembly required, basically just turning on things in a configuration file if you want it. It will take 5 seconds. So this is where I leave the slides and actually do it. So I have a Windows XP 64-bit system here, and I have it running at 102 IP and my attacker running at 103. So what I'm going to do is, in my first example, I'm going to actually clone, host a website, a version of a website that perhaps I can get the user to visit. And I'll talk more about that as I do it. And then host malware on it that, if the user lets it run, will totally own the system. So start set, and hopefully the demo works. So can everyone see that? The bottom left? Okay. It provides various different options. Everything is almost numerically commanded. I'm just going to select social engineering attacks. And then it presents me a next menu. Do I want to select spear phishing attack vectors, website attack vectors, infectious media, payload listener handlers, mass email attacks, Arduino-based attacks, text message spoofing attacks, wireless access point basically spoofing attacks, similar to what Metasploit does. There you have the QR attack vectors, and then third-party modules and stuff like that. So we're going to go with just basically website attack vector. And I'm going to go with the Java applet attack, which is the first one. But I'll talk a little bit about the second ones, the next ones. So option 2 is Metasploit browser exploit method. It essentially will host on this website that you're about to spawn a exploit that will utilize a vulnerability in the victim's browser. Say they're running an old version of Internet Explorer, and it hasn't been patched and has a vulnerability. It will exploit it, hopefully. Your mileage may vary here. Exploitation is a tricky part. There's a lot of nuances that can cause things to fail. But it has functionality to support that. It also has really cool functionality to completely man-in-the-middle, harvest credentials, and then pass off the connection as if it never happened. So essentially, it will scrape and clone the whatever page you give it for the domain. Say it's bank.com. And so you go to bank.com, and if you navigate to the attacker's version, you'll be presented with an exact clone, and you have the login password prompt. If you decide to log in without the HTTPS, it'll pass basically the password and username and password credentials to the attacker. The attacker will store them, and then it will pass off the connection back to the original website and disconnect itself from the mix like it was never there. And it's all completely automated. And there's various other ones that are really interesting. So I'm going to, because I have to talk about the midterm, just jump right to the Java applet attack method. So the reason why I'm using this is because it's Java, and I don't really need to say much more. Okay. So the thing about Java applets is that basically Java allows it allows you to assign an applet with any name you choose. So you can totally fudge the certificate, and so you could say this is signed by Bill Gates from Microsoft in the trusted apps development team, and you could have trusted, 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 trusted all over the certificate. And you might actually fool someone, because most of the time when people are asked about certificates, they say, yeah, I trust it anyways. So given a large enough company, corporation with thousands of people, you're guaranteed to have success with this. So this attack vector provides an applet that auto-detects the user's browser type, and then for that browser type, delivers a custom payload to that victim's machine. And so actually Java does not consider the means by which it does this to be a vulnerability in Java at all. In fact, it's a feature. So this will never, ever, 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 ever get fixed. So it is highly effective as well, because it's Java. And I'm sorry for circular logic, but I think they use a lot of that too. So The next step here, I've selected that I want to use the Java applet attack method. I can choose to use an existing template, or I can actually clone an exact site that I want to use. Here I'm using host-only adapter between my virtual machines, so it does not actually have access to the network. So I can't do that. Or I could import a custom website of my own design. I'm just going to go with a standard template. It asks you basically about NAT and port forwarding details. I'm going to select no because in this instance I am on the same LAN as the victim. So I need to specify my IP address, which is going to be 103. Who can tell me what the problem with this forensically is? Yeah, I'm revealing some information about my, basically, attack. So there's 5 examples. I'm going to choose the one for Twitter. So it's going to be a clone of an old version of Twitter. And now I have to specify the payload that I want to generate. Since this is a 64-bit system, I need to have 64-bit exploit. So what I'm going to do is a Windows interpreter reverse TCP for 64-bit. I'm going to use the default listener. And now set is actually going to go through the process of setting everything up. So hopefully it all works. So here it's dynamically generating the shell code for 2 different architectures, just because it's designed to be flexible and detect basically which version of the browser the user is using. Obviously, the 32-bit and the 62-bit version of the application will differ, so they have to have basically the applet shell code that applies, applet code rather that applies. So I should note that the payload I chose was Windows specific, so even though it's attempting to generate it for OS X and Linux, it's probably not going to work in those instances. So it's finally actually launched the website. It started Apache and launched the website, and it's given me very verbose information because I've configured it to. And now if I happen to, as the victim, have my website, my traffic direct me to this URL, to the IP address of the attacker, who can tell me how that could be accomplished? Exactly. RSpoof, or you could forge DNS, basically, replies, intercept if you had to. So you see that we get a website here. I don't know why it's a little slow, but these things happen. So what happens right away is that I'm prompted as a victim to allow access for this applet to run. Now anyone with half a brain is going to say no. But like I said, given a large enough company, you have thousands of people, you have people working in accounting, they don't know this stuff, they may say yes. Besides, it says secure. So even if you did, you click more information, there are some problems in here because I used it just like totally out of the box. The signature has expired and various other things. But Actually, I have slides on this, so I'll skip past this. You can configure the details of the certificate. So if I say I accept this and I want to run, I hit run. You can see this activity going on in my Metasploit session. And if I look at sessions, I have one actually that has been caught and is currently being listened to. So this exploit has worked. So now I want to actually take, I want to switch my context to this interpreter shell. So I do sessions -I and type ID. So the ID for this one is 1. So I have interpreter access now. I'm going to look basically at the details of this box, and I look at the IP address information for it, and it is clearly not my IP. So this is a successful exploitation of the victim. And look how little I actually even had to do to actually pull this all off. It's hilariously easy in the cases that it does work. So social engineering is widely being recognized as the easiest way to pwn people. If you do actually go to DEF CON, you should totally check out the social engineering capture the flag. Chris Hadnaghi, keep getting his name wrong. He hosts it. It's totally awesome. It's so awesome that actually the head of the NSA stopped by to visit it and gave him one of his golden coins. He only gives about like 5 of these out to like the top people in the world. And so these are like people that we don't even know who exist and stuff like that. So that's how important this stuff is, because it's hilariously easy.
So next time, we're going to talk about post-exploitation and using the interpreter more, doing things like killing the antivirus, evading IDS and defenses, pivoting into other processes, into other targets, passing the hash, and so much more. And that's it for today's lecture. There's no required reading for this video. Good luck on the midterm.